Hello everyone, sorry for slight delay. There was some technical issue at my end. So yes, motivational for hello. How are you all? So today the class was supposed to start around 5:30, but due to, as I mentioned, some delay happened. Some studio camera stopped working, so I had to fix that. And yes. So we are going to discuss the second part of our second PUC FA-1 preparation. And as you know, we have already covered two chapters in part one. That is very important: electric charges and field, as well as um, electric potential and capacitance. So those two chapters are done. Now today I am going to discuss the remaining two chapters: current electricity and moving charges and magnetism. Now note, moving charges and magnetism entire chapter is not there, only up to a magnetic field due to a circular current carrying coil is there, and beyond that galvanometer etc are not there. I am not going to discuss those questions anyway. Okay, so I'm going to discuss only whatever is in the syllabus and whatever is important, right? And this is going to be very important for all of you. And if you are watching live, try to answer the MCQ questions along with me. That will give me motivation to do something better throughout the lecture, right? So let's start with the session. Just give me a moment, fix my pen, and let's start. So first, obviously the chapters current electricity and moving charges, these two chapters we are going to cover. And as I mentioned, moving charges, we are covering almost half of the chapter, not the entire chapter, right? Now let's start with current electricity or electric current. Statement based questions. First, the resistivity of metals increases with increase in temperature. Statement number 2, increasing the temperature of metals causes more frequent collisions of electrons. So resistivity uh, increases with increase in temperature. Obviously that is the true thing. If you increase the temperature, the resistance also increases. Now why does that happen? Because as you increasing the temperature, the electrons are colliding more frequently, their kinetic energy increases, and as the kinetic energy increases, they are prone to more collisions, and more collisions means slowing down means current is flowing slowly, and current is flowing slowly means definitely resistance is increased. So obviously statement 1 and 2 are true, and 2 is the correct explanation of number 1. So option A is correct statement. Option A is correct option. Motivational is saying, sir, enhance my voice. My voice is actually maximum motivational. You can do one thing, that you can use some earphone. If you are not using any earphone, try to use some earphone, right? If I enhance my voice much more, then what will happen is that there will be some noise will come, right? And I am the loudest teacher of all the teachers that is available that those who are teaching in our channel, right? And if there is still any issue, that means check your device once, and if you are still not having, if you are still having issue, do one thing: open your Chrome browser and open the YouTube in the desktop mode, so that you can follow our channel directly from there. Also sometimes the voice can be an issue with the YouTube itself, right? Just give me a moment. Okay, now let's see. Next question, question number 2. Identify the wrong statement from the following. The drift speed acquired by, so wrong statement means out of the 4 things that is here, 3 of them are actually correct, only one is wrong. So that wrong statement you have to find. So not the finding the correct answer, finding the wrong answer is correct here. The drift speed acquired by free electrons per unit electric field is called mobility. So drift speed acquired by electron per unit electric field. So mobility is defined by drift speed per electric field. So this is correct. Okay. Next is, the conductivity of semiconductors decreases with increase in temperature. So conductivity of semiconductors decreases with increase in temperature is wrong. So for normal metals, if you increase the temperature, conductivity decreases, but for semiconductors, if you increase the temperature, conductivity increases. So this is a wrong statement. This is our answer. Let's check the other two options as well. So whenever you are answering, always make sure you read all four options. You will always get enough time to read all the options. The conductivity of conductors decreases with increase in temperature. So conductivity of conductors decreases with increase in temperature. This is the correct statement. Alloys are widely used in the construction of standard resistors. So if you see the standard resistance box that you use in your laboratory are made by nichrome or manganese, okay, because they are super duper heat resistance, and their resistance does not change over temperature. Okay, if you even if you change the temperature by thousands of degrees, their increase in resistance is very small. That's why standard resistors, where the resistance has to be fixed, are being used by are used to are alloys are used to manufacture those standard resistors. Okay, so this is also a correct statement. So option A, C and D are correct statement. Option B is incorrect. So that incorrect or wrong statement is option number B. A wire has a non-uniform cross-sectional area as shown in the figure. A steady current I flows through it. Which of the following statement is correct? So here we have a conductor through which current is being flowing. Okay. The drift speed of the electron is constant. The drift speed of the electron increases while moving from A to B. The drift speed of electron decreases while moving from A to B. The drift speed of electron varies randomly. So let's see. So normally most of you will be tempted to answer the first one, drift speed of electron is constant. Actually it is it is not the correct answer. Remember, drift speed into cross sectional area is constant. For a given current, when the current is constant, if I is constant, then drift speed into area is constant. Okay, not drift speed alone. So if you look into this diagram, here we have a area A, here we have an area B. Suppose drift speed over here is say VA and drift speed over here say VB. Okay, now as I mentioned that VA into area A equals to VB into area B, right? Or VA upon VB equals to B upon A, right? Now if you look into this equation, you will realize that area B is greater than A, right? In the diagram, area B is greater than A. That means this quantity must be greater than 1, because B is a bigger number, A is smaller number. So if you divide say 2 by say 1, you will get 2, which is greater than 1. Or even if you are dividing say 5 by 4, that is also greater than 1, right? So the right hand side is greater than 1, that means left hand side should also be greater than 1. That means VA must be greater than VB. So as the current is moving or electrons are moving from A to B, the drift speed is decreasing. Okay, the drift speed of electron decreases while moving from A to B. So option C is correct answer. Make sure you understand the question properly and then only answer. Do not just randomly answer any option. If you are confused, read the question, try to figure out what formula, what is the foundation behind that question, and then only answer such questions. Okay, now let's move on. Question number 4. The resistivity of a metallic conductor dash with decrease in temperature. So resistivity of a metallic conductor dash with decrease in temperature. So increases, decreases, first increase, then decrease, first decreases, then increases. So resistivity of a metallic conductor always increases with decrease in temperature. Resistivity and resistance, they both decreases as you decrease the temperature. Okay, resistivity and resistance increases with increase in temperature, decreases with decrease in temperature. So it will be decreases. Resistivity and resistance, as you are lowering the temperature, electrons, vibration between electrons are reducing. that means the resistance improves, the resistivity improves. Okay, so answer for this question will be decreases, not increases. Okay, now next question. Just give me a moment. Next, Kirchhoff's junction rule is a reflection of. So there are two rules of Kirchhoff's junction rule. Uh, just a second. I think there is some issue with my camera. Yeah, it is fixed. So Kirchhoff's junction rule is a reflection of. So what is the junction rule? Junction rule means when multiple currents are meeting at a point. Suppose some currents are meeting over here, some currents are exiting. Okay, this is called Kirchhoff's junction rule. So total incoming current is equals to total outgoing current, right? So total sum of current in is equal to sum of current out. And if you see what is current, current is actually charge divided by time. So if you keep the time fixed, okay, then Q will be equals to I into T, right? So that means whatever charge is incoming, that same charge has to go out at this junction. This is an isolated point. So this actually represents the conservation of charge. This actually represents conservation of charges. Whereas Kirchhoff's circuit law, or sorry, Kirchhoff's circuit law or Kirchhoff's loop rule, that reflects the conservation of energy. Kirchhoff's junction rule is for charges. Kirchhoff's loop rule is for energy. Okay. Now let's move on. In the absence of an electric field, the mean velocity of free electrons in a conductor in absolute temperature T is. So in the absence of electric field, the mean velocity of electrons in a conductor in an absolute temperature T is 0. If there is no electric field, electrons will move randomly without any particular direction. Their average or mean velocity will be 0. So that means answer will be 0. Okay, so in the absence of electric field, the mean or average velocity of electrons will be 0. Okay, next question. Ohm's law is valid when temperature of the conductor is very low, very high, constant, varying. So Ohm's law, if you remembered, the constraint of Ohm's law was that uh, temperature and other physical conditions remaining constant, right? So that means temperature has to be constant. It cannot be varying. It cannot be, in fact, at very low and at very high. Ohm's law is not valid at all. So that means only option is constant. Even if it is varying, the Ohm's law is not completely valid. Okay, so only one condition, main condition of Ohm's law is temperature has to be constant. Next, in the equation AB equals C, A is the current density, C is the electric field, then B is resistivity, conductivity, resistance, or potential difference. So, Ashwini, if you are answering, try to mention the question number so that I will know which question you are answering. Right, Ashwini? So mm, if you are able to not able to hear me, please check your device volume, because I can hear myself clearly and loudly in this in my device, right? Let me check once more. Just give me a moment, guys. Give me a moment. I am trying to. Okay, Ashwini. So if hmm, just give me a moment. Just reply in the comment that if you are able to hear me clearly or not. Just tell me right now. Okay, if you can hear me in the comment, I have changed my device battery. So if you feel any audio issues, you can hear me, right? Thank you, Ashwini. Thank you for confirming. Thank you. Thank you for confirming. Now I can continue with the class. I think there was some issue with the battery. So I have changed the battery and I think it will be fine now. Okay. Now in the equation AB equals to C, A is the current density, C is the electric field, then B is. So resistivity, conductivity, resistance, potential difference. Let's see. So we know that what is given, A is current density. So current density is J. Okay. Uh, B is unknown and C is electric field. Okay. Now, if you remember, their alternate form of Ohm's law is given by J equals to sigma into E. What is this sigma? Sigma was conductivity. Right? Now, here the equation is not the same, but yes, we can see J and electric field both are given, but B is not on the side of E, but it is on the side of J. So what to do? So what we have to do, we have to take that sigma on this side and we have to write it like this. So J upon sigma equals to E. Now what is this quantity? 1 upon sigma. 1 upon sigma or 1 upon conductivity is called resistivity. So this is resistivity. So that means J into rho equals to E. So that means rho B is equals to, therefore B equals to rho. That means the B is resistivity. B is resistivity, not conductivity. Obviously, not resistance or potential difference. It is resistivity. So be careful. This is a question in one of the oldest KCET paper, and now this kind of questions can be asked in your PU board exam as well. So be careful. The relaxation time in conductors increases with increase in temperature, decreases with increase in temperature, is independent of temperature, changes at 400 K and above. So relaxation time means what? So if you don't know the answer, try to figure out the basic concepts. If you can figure out basic concepts, Ram Good evening, sir. At the MCQs and numericals of two marathons enough for those who two sections of FA-1, sir? Yes. Yes, resistivity. So yes, Ram. So both sessions should be sufficient for you to score well. With a little bit more practice, you can score 35 plus, 35 out of 35. If you are at least watching these two marathons, 30 marks is guaranteed. Provided you are also solve the numerical question. Numerical questions, I have solved some numerical questions in our previous class. Today also I am going to solve few standard numericals in current electricity. Obviously, the exact numerical questions will not come, but questions based on or concept based questions will definitely be repeated. And if you are lucky, obviously 5 marker derivation, 2 3 marker questions will be common. MCQs, there will be few tricky MCQs, there will be some easy MCQs as well. So if you are able to figure out the tricky MCQs, then obviously 35 out of 35 is guaranteed. But if you are not, 30 is guaranteed. 30, if you are watching these two marathons, 30 is guaranteed from my side. Okay, all the important questions is being discussed over here. Yes, in the exam hall you will be able, there will be 3 questions, out of that 2 you have to write. So obviously 3 questions will not come common, but 2 questions you will be able to get common, right? That is obviously that happened in the past, and that will going to happen in this year also. Don't worry. Okay, you can ask your seniors. I solved some questions on the day of the exam for PU board, and the same questions came in the in the final exam also. I predicted this is going to come, and that question actually came in the board exam. Okay, so that is one assurity that I can give. Yes, in FA1 and midterm paper, because the full syllabus is not there, there are some uncommon questions might come. But yes, if you following these two marathons, definitely your results will be very good. That is my promise. Now let's start. In relaxation time of conductors, uh, Ashwini is Srivesh is saying C, independent of temperature. No. So if you are increasing the temperature, what happens? The electrons are vibrating more. Vibrating more means their collision is increasing more. Okay, and more collision means, what is relaxation time? Relaxation time is the average time between two collisions, average time between two collisions of electrons. So when you are increasing the temperature, the collision frequency increases, so electrons are colliding more frequently. So more frequent collision means what? The uh, uh, relaxation time decreases. Okay, as you are increasing the temperature, the relaxation time decreases. So the electrons are not very relaxed. For example, as the exams are approaching, if you are writing too many exams, your relaxation is gone. I have to write this exam today, next today is Canada and biology, tomorrow is physics and chemistry, like that, right? So as your exams are approaching, your relaxation is decreasing. Same with the electrons, as their temperature is increasing, their relaxation time is decrease as the temperature is increasing, relaxation time decreasing, right? So decreases with increase in temperature, it is not independent of temperature. Hello Extreme, how are you? Yes, I remember you. You are one of our regular student in my last year's batch. I hope you are doing well. Your how was your counseling? Which college you got? Okay. With increase in temperature of the conductivity of semiconductors, so increase in temperature. So temperature is one of the most tricky subject in this chapter, right? Even though this chapter talks about current electricity, but there are a lot of questions that is based on the concept of temperature. Okay. With increase in temperature, the conductivity of semiconductors and metals decreases. So if you are increasing the temperature, conductivity of semiconductors becomes more increases, and for conductors it is decreases. Conductivity, remember, so at higher temperature a semiconductor becomes a better conductor, whereas a normal metal becomes a bad conductor. right? So as you are going higher and higher, a semiconductor becomes better and better, metal becomes worse and worse. So that means metals decreases and semiconductors increases. Okay, so conductivity of semiconductors increases and metals decreases. So option A is the correct answer. So as you are increasing the temperature, semiconductors conductivity increases. That means it becoming a better conductor, whereas metals are becoming bad conductor. Not exactly bad conductor, but they are relative to their previous normal room temperature conductivity decreases. Okay. Now next is fill in the blanks. I forgot to erase the answers. Anyway, let's see. In a current carrying conductor, the net charge is, in a current carrying conductor, the net charge is 0. Very interesting. In a current carrying conductor, net charge is not some value, it is actually 0. Okay, even though you might think that, okay, sir, in a conductor it is carrying some current, there must be some extra electron in it. Actually, no. Okay, when you apply, suppose you are having some resistor, okay, through the resistor, this is very interesting topic. So just understand it once. Okay, so what happens is that when through a conductor some current is flowing, some electrons are escaping from this side and some electrons are coming back to the positive side, right? So electrons are exiting the negative side and they are entering through the positive side. So at any given moment, the total electrons and total number of protons are same in the conductor. That means what happens is that the net charge is still 0 in a conductor, no matter how much current is being flowing in the circuit. So that is also super important concept. This can be asked in a MCQ also. Okay, the magnitude of drift velocity per unit electric field. So drift velocity per unit electric field is called mobility. So that is what is written over here. The SI unit of electric resistivity is ohm meter. Okay, ohm meter is unit of resistivity. Okay, the resistivity of certain metals or alloys drops to 0 when they are cooled below a certain temperature. This phenomena is known as superconductivity. This phenomena is called superconductivity. So when you are decreasing the temperature to absolute 0, their conductivity resistivity of certain metals actually 0. That means it is a perfect conductor. Okay, and those conductors are called superconductor. This is a very new branch of physics where a lot of research is being done. If you study physics or advanced electrical physics, electrical engineering, maybe you will do lot more research on superconductivity. The Kirchhoff's loop rule is based on the law of energy, conservation of energy. I already explained it. Loop rule is energy. Junction rule is based on the conservation of charges. Now, let's move on. Define drift velocity and mobility of free electrons in conductor, or define mobility, mention its SI unit. This is also a super important concept. So define drift velocity. So either they will ask you the drift velocity, okay, and conduct mobility, or they will ask mobility and its unit. Drift velocity's unit also can be asked. So I will tell you what is the unit of drift velocity, something completely new thing. The average velocity with which the free electrons drift under the influence of electric field is called drift velocity. What is the unit of drift velocity? The unit of drift velocity is nothing new. It is same as velocity. Okay, I just tried to confuse you. Remember, drift velocity's unit is meter per second. Yes, same as velocity or speed. Okay, so drift velocity is also a type of velocity with the average velocity. Electrons are actually moving in the presence of an electric field. In the absence of electric field, drift velocity is 0. Okay, electrons do not drift in the absence of electric field. If there is an electric field, then only electrons drift, and then you get a drift velocity, and that is meter per second. Mobility. Mobility of free electron is defined as the drift velocity of electron per unit electric field applied. Okay, so mobility is drift velocity per unit electric field. So what is the unit of drift velocity? Meter per second. What is the unit of electric field? Newton per coulomb. Okay, so its unit is coulomb meter per Newton second. Okay, so its SI unit is uh, coulomb meter per Newton second, or meter square per second into volt, or as I mentioned, a meter per second Newton per coulomb. But because it is in division, it is written like that. You can write this also, coulomb meter Newton per second, Newton second, that is also accepted. Okay, those official, I just tried to fix the volume, it is still low. See, now in my device, the sound is coming perfectly. I just change the battery, and the voice should not be low anymore. Is it still happening low voice? Just let me know if you can. Just tell me if the voice is still low or not. Just give me a moment, please. Just give me a moment. I will check from the outside. If the voice is still low, then I have to fix something. Hello, hello, hello. Okay. So we have done some technical correction. If the audio, if you are not able to hear me properly, because in my monitor it is showing that volume is good. Okay. So now I think the audio should be perfect, right? And if you still not able to hear me, let me know once more. Okay, dost. I hope it is okay now. I have done some corrections. Please tell me if the audio is low or not, because test how to read. Srivans is saying how to read. How to read, I do not understand what is the meaning of how to read. Okay. Okay. So let's continue with our discussion. So the mobility is the mobility of free electron is defined as the drift velocity of electron per electric field, and the SI unit of electric field is electric mobility is coulomb meter per Newton second. Okay. Okay. So Srivansh, N Sri NS Viresh, NS Viresh, what is the meaning of how to read? How the read? I don't understand the point. How the read? What is the meaning of how the read? What is the meaning of how the read? Please. Okay, let's move on with the next question. Mention two limitations of Ohm's law. Another super duper important question. Two limitations of Ohm's law. Ohm's law is applicable only if all the physical conditions remain same. Ohm's law is not applicable at very low and at very high temperature. Ohm's law is not applicable to non-ohmic devices like semiconductor devices, discharge tube, etc. So these are the three basic points that you have to write when they ask you what is two limitations of Ohm's law. Okay. NCRT book, how to read? Okay. So in NCRT book, what you can do, first of all, if you are going through, I do not recommend NCRT for the derivations and etc., because derivations and etc. is given in a very long format in NCRT. But you have to go through the description of each and every concept. So read the book carefully. So for example, if you are finding this limitations of Ohm's law, it is not given like this, but it is given as well as some explanation is given. So out of that, you have to underline what is this point. Okay, Ohm's law is not applicable to all if physical condition only if all physical condition remain same. Physical condition means suppose there is a metal which suddenly melt, then Ohm's law will not no longer be applicable. But this explanation is there in the NCRT. You have to figure out the statements. Secondly, when you are studying some derivations, you have to write down the derivation on your notebook on your own, so that in the NCRT they have given some derivation, started with some derivation, suddenly they change it, they added some explanation for this equation, and then they went to do the remaining of the derivation. So that is also not recommended. You have to do the derivation properly. So whenever you are doing the derivation, write it down on your notebook properly and thoroughly. Lastly, very important part is that when your chapter is completed, okay, you have to go through the summary of the chapter. Summary of the chapter in NCRT is very good tool to revise the chapter in a short duration. Okay, and whenever you are studying NCRT, underline the important points that you feel, okay, from this I might be able to, there might be a question. So whenever you are reading NCRT, always ask yourself, is there a question possible from this line? Yes, underline it. If you feel that, okay, now no, this is generic line, this is a normal statement, no questions can be asked, do not need to underline it. But if you feel that okay, Ohm's law, Ohm give the law in 1987, suppose. So is there a question possible from this? Maybe, but most likely not. But Ohm's laws condition that Ohm's law is applicable for non-ohmic, not applicable for non-ohmic conductor. Is there a possibility that there will be a question from this? Yes, highly possible. So underline it. Right? Clear? Okay. Next question. Give any two differences between current and current density. So current is defined as the amount of flow of electric charge per unit time. Okay, current density on the other hand is the amount of current per unit area. Okay, unit of current is a, unit of current density is ampere per meter square. This is also common question, especially for FA-1 and midterm. Okay, easy definition. First point is definition, second point is unit. Okay, current is obviously charge by time, so remember current is given by charge by time, and current density is current per unit area. Okay, if you remember that, your 2 mark is guaranteed. Next, name two factors on which the resistivity of a metallic wire depends. Here it is resistivity. Make sure this is resistivity, this is not resistance. So how to remember that resistance and resistivity, they are completely two different things. If you remember, resistivity depends on resistance depends on rho L upon A. It depends on the material, it depends on length, it depends on area. But resistivity does not depend on length or area, it only depends on material of the wire and the temperature of the wire. Okay, otherwise resistivity does not depend on anything else. Okay, next, write the expression of drift velocity in terms of current. Explain the term used. Super easy question. Drift. We know that current is given by N E A V D. So V D or drift velocity is given by I upon N E A. What is I? I is current. What is N? N is number density of electrons. Okay. E is charge of an electron, equals to 1.6 into 10 to the power of minus 19 coulomb, and A is the area of cross section of the conductor. Okay, so you have to write down this equation and explain all the terms involved in here. And one very important thing, if you want to get the notes from here, then what you have to do, you have to go to our video. I will explain briefly, just give me a moment. So if you want to download the notes, what you have to do, you have to come to our channel. Obviously, the live is going on. Click over here. Okay. And then you come down where the description is given. This is the description section. Click more, and here you will see that join the free ACE 2027 batch. Click over here and you will be redirected to this page, and here you have to click on buy now, register using your mobile number and few basic details. Once you have done it, then it will be automatically redirect you to the page, and you will get this free YouTube course. And here you will get weekly tests, you will be getting assignments, everything will be given to you absolutely free of cost. You don't need to pay anything. Even Ask Ved is also there. Okay, and you can go here and you will get the all the lectures that we have done in our channel, and you can even download the notes as well. From this you can download the notes. Okay, you can have some quiz, you can have some smart notes as well. Okay, unfortunately there is no smart note for this session, but yes, all the notes and mm, lecture related PDFs will be available in this platform only. So go there. Also assignments, soon assignments will be added, tests will be added for your KCET preparation. So here you will get all in one place, all the lectures that is we are doing in YouTube. You can watch it without any distraction. Here no ads, nothing, right? And also one more important part is that all the lecture notes etc will be added in this platform only, right? Shrivesh, we will take another 1 hour. Okay, another 1 hour we will try to complete the class. Yes, if you have Monday physics exam, then this will be a very good revision for you, right? So but anyway, derive the expression for drift velocity in terms of electric field and relaxation time. Now, what is drift velocity? Drift velocity is given by, so we have an electric field applied to a conductor. Okay, some electrons are moving, and electrons are moving in the opposite direction of the applied electric. You have to find the electric drift velocity in terms of drift electric field as well as relaxation time, right? Now how to do that? Now we know that current in a conductor is given by I is equal to NEA VD. Okay, current is given by NEA VD. Now we also know that from Ohm's law, uh, E is equal to, sorry, J equals to sigma into E. Okay, J equals to sigma into E. Now if you can find J and replace it with sigma E, we can find some value, right? Let's see. So if you replace I upon A equals to NEVD, right? I upon A equals to NEVD. Now what is I upon A? I upon A is current density. So J is equal to NEVD, right? Or we can write here E, sorry, J is equal to sigma E. Sigma E is equal to NEVD. Okay, or VD equals to sigma E upon NE. Okay, this is the formula in terms of resistivity and electric field. Now you have to replace it with the current density. Sorry, you have to replace it with the relaxation time, right? Hello Akash, how are you? Now in this equation you have to replace another equation, that is the expression for resistivity. Resistivity is N E square tau N E square tau upon M. Okay, resistivity is given by N E square tau upon M. If I am not mistaken, this is the expression. And if you substitute this over here, you will get N E square tau upon M into sigma E upon NE. Obviously, N cancels, E, one of the E will be cancelled, and sorry, we have substituted sigma, right? So E upon NE. Okay, N cancels, one of the E gets cancelled, and you get uh, small e capital E tau upon M. So this is the expression for drift velocity in terms of electric field and relaxation time. Now remember, generally there is a negative sign. Why negative sign? Because when you are applying electric field, electrons are moving in the opposite direction. To honor that, we add a negative sign over here. So drift velocity is in the opposite direction of electric field. To just to showcase that, we add a negative sign. So at the last stage, you have to mention why it is negative, because drift velocity and electric field are in the opposite direction, so that will be a negative sign. Okay, let's move on. Two cells of different EMFs and different internal resistances are connected in series. Derive the expression for effective EMF and effective internal resistance of the combination. So this is the cells in series. Cells in series means cells in series, cells in parallel, and Wheatstone bridge. Three derivations that might come from this chapter. All of them are super important. If you practice it once, it will remain with you till your board exam. Okay, this is not like only once you are practicing and forgetting for remaining exam. No, if you practice it today, it will stay with you till your board exam. So let's see. So here, uh, cells in series means we have two cells back to back. Suppose this is EMF 1, resistance R1, this is EMF 2, resistance R2, and this entire combination is connected across an external resistance of R. Okay, so this is the cells in series. Now if you can replace these two cells with only one cell and only one internal resistance, but the external circuit remains same. Okay, so this is called equivalent EMF, this is called equivalent resistance. Okay, the current in the circuit, whatever current that was flowing previously, the same current is flowing now as well. Now how to solve this question? Now obviously we will apply Kirchhoff's laws to simplify it easier. That will be much easier for us. So we will say this is the resistance, these are the all the resistance current, whatever current entering the circuit, same current has to exit the circuit as well, right? So current is constant, so we will basically apply I into R plus I into R1 plus I into R2. These are all the voltage drop across the resistors. Okay, voltage drop across the resistors should be equals to sum of the EMFs. Now both the cells are sending the current in the same direction, so they are getting added. So we get IR plus I into R1 plus R2 equals to E1 plus E2, okay, or IR equals to E1 plus E2 minus I R1 plus R2, right? This is equation number 1. Now we will use the same thing on the equivalent circuit as well. In the equivalent circuit, again the current is I, current through this internal resistance is also I, same current is flowing, right? So again we can write IR plus I R equivalent equals to E equivalent. Okay, this is from the equivalent circuit. Series 1 is very easy. IR equals to E equivalent minus I into R equivalent. Right, so both side of equation 1 and equation 2 are same, so right hand side should also be same. Now if you compare the similar terms, comparing similar terms, okay, we can write E equivalent equals to E1 plus E2 and R equivalent equals to R1 plus R2. Now why this is possible? Remember, this is possible because of this I. This I is there in the multiplication. That means whatever factor that is getting multiplied with I should be same. So these two must be same, and if this is same, then that must mean that these two also are same. Okay, so comparing the similar terms, we can say this must be equals to this, and what is happening? Okay, and this R equivalent must be equals to R1 plus R2. Very important but easy derivation. Next one is slightly tricky. Derive the expression for effective EMF and effective internal resistance of two cells of different EMF and internal resistances connected in parallel. So in parallel combination can be tricky. So here this is E1 R1, this is E2 and R2, and this combination is connected across an external resistance. Obviously, if we replace these two combination with only one, we will get this. This is the epsilon E equivalent, this is R equivalent, and this is the external resistance. Suppose the current passing through this is I1, current passing through this is I2. Total current in the circuit is I equals to I1 plus I2. So I equals to I1 plus I2. Here the total current is I. Okay, this is slightly tricky. Obviously, you have to individually calculate the I1 and I2 and then compare something. Let's see. So first we will go through this circuit. So this loop, first we will consider the loop containing E1. We are applying Kirchhoff's law. So Kirchhoff's law means this loop is one loop. For this loop, obviously, as I mentioned, whatever current is entering, the same current has to exit. Okay, so that means I1 is coming out, so I1 must also go back. So for this resistance, I1 R1, and for this capital R resistance, it will be I into R, and that should be equals to the given EMF, which is E1. Okay, so I1 R1 equals to E1 minus IR. So this is a slightly different steps. Okay, here our main target is to find I1. So that will be E1 by R1 minus IR by R1. Okay, similarly for loop containing E2, we can write I2 equals to E2 upon R2 minus IR upon R2. Okay, so this is the first step. Now what? Now we have to add these two currents so that we get the total current. So total current is I1 plus I2. That means E1 by R1 minus IR upon R1 plus E2 upon R2 minus IR upon R2. Okay, now obviously we take same thing common. So E1 by R1 plus E2 upon R2. This is 1. And we get the other one as minus IR as common. We get 1 by R1 plus 1 by R2. Now we will separate. So this is our I. Now we separate the IR part. Okay, the same as the previous step. Okay, now we separate the IR part. So we get IR into 1 by R1 plus 1 by R2 equals to E1 by R1 plus E2 by R2 minus I. So what we have done? We have basically taken this negative minus IR on this side and this I on the other side. Okay. Now we will divide it. Our main target is to separate IR. So IR equals to E1 upon R1 plus E2 upon R2 divided by 1 by R1 plus 1 by R2. So this one we have divided on the other side, minus I divided by 1 by R1 plus 1 by R2. Right? So our IR separation is done. Now for equivalent circuit, we can write IR plus I into R equivalent equals to epsilon equivalent, or IR equals to epsilon equivalent minus IR equivalent, or F E equivalent minus I divided by 1 by R equivalent. Right? Division of division is multiplication. Why we have written it like this? Because here if you see, the I is on the top and the resistance is in the division. Just to match these two, we have written it like this. So comparing equation 1 and comparing equation 1 and 2, now we can write epsilon equivalent is given by E1 upon R1 plus E2 upon R2 divided by 1 by R1 plus 1 by R2, and 1 upon R equivalent equals to 1 by R1 plus 1 by R2. Obviously this is a parallel combination, so resistances are getting added parallelly and EMF is slightly complicated, but if you remember like this formula, E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2, then this will help you to memorize the entire formula much longer. Okay, so this is the formula for epsilon equivalent. Remember the steps: first calculate I1 and I2, first calculate I1 and I2 individually, okay, with help of whatever Kirchhoff's equation you are going to get, and then add them to get the I. Now separate IR. In series combination, IR is getting you are getting IR directly, no need to do complicated mathematics, but here IR is not be able to get directly, so you have to take this kind of route. Okay, and once IR is separated, you write the equivalent equation as well. From there also you take the IR as common and then you find the R equivalent. Okay. Now next, arrive at the balanced condition of Wheatstone bridge using Kirchhoff's rules. Okay, this is also super duper important. Okay, what is Wheatstone bridge? Wheatstone bridge is like this, like Kaju Katli. Okay, this looks like Kaju Katli with the central part is being added with a galvanometer. Okay, now this is P, this is Q, this is R, this is S. Now this derivation can be tricky if you are doing it wrong. Okay, I will teach you a shortcut method through which you will be able to answer this quickly. Okay, now this current Ig is the galvanometer current. Okay, at balanced Wheatstone bridge, the condition is Ig must be equals to 0. So galvanometer will not show any deflection. The main way to design it is that you design this circuit such a way, you adjust the resistances such that the galvanometer current becomes 0, then you say that the bridge is in balanced condition. Okay, and this potential of these 2 points are same, and this is a way to measure unknown resistances. Okay, generally we have 2 fixed resistances, one variable resistance, one unknown resistance. Okay, if you change the variable resistance such that the bridge gets balanced, then we say that we can find out the unknown resistance. This is the way of measuring unknown resistances. Okay, now, so the condition of balanced is Ig being 0. So as Ig being 0, then uh, we can say I1 is going into this junction. Okay, so let's say A, B, C and D. These are the 3 points. So at the junction B, I1 is going in, Ig is coming out, I3 is coming out, right? So from Kirchhoff's laws, we can say I1 equals to Ig plus I3, but as Ig equals to 0, therefore we can write I1 must be equals to I3. Similarly, I2 must be equals to I4. Okay, Ig is 0. That means whatever current is going in, the same current has to come out, right? This current being 0. Same here, whatever current is coming up to point D, the same current has to go out. Okay, Kirchhoff's junction rule. So I2 equals to I4. Right? Now we apply Kirchhoff's loop rule. Applying Kirchhoff's current law, or Kirchhoff's loop rule, same thing. Sorry, Kirchhoff's voltage law at loop. Loop means what? Loop means if you are going in a path such that your starting point and ending point are same. So if you go from A to B, B to D, D to A, then A, B, D, A, this is a loop. Loop A, B, D, A. So if you see that, I have not written it by mistake. The starting point and ending point are same. That means it represents a loop. Okay, this is not a rectangle or a triangle or nothing like that. It is a loop. Starting point A, B, D, A. Okay, if I just write A, B, D, this is a triangle. But if I say A, B, D, A, then it's a loop. Okay, so A, B, D, A loop. In this loop, we are going from A to B, B to D, and D to A. So this is the resistance P, this is the current I. So P into I1 plus Ig into G. Now from D to A, we are going in the opposite direction. From D to A, we are going in the opposite direction. So it will be minus R into I2. And there is no battery connected in this loop, so that must be right hand side should be 0. Now Ig equals to 0. Therefore, Pi1 minus Ri2 must be 0, or Pi1 equals to Ri2. This is my equation number 1. Okay, this is my equation number 1. Now we are going to do the same thing for the loop BCDB. Okay, loop BCDB. In this loop, we are going to do the same thing. I3 into Q. I3 into Q minus I4 into S minus I4 into S and minus Ig into G. Obviously, Ig being 0. We can write I3 into Q equals to I4 into S. Right? Now, we also know that I1 equals to I3. So I3 can be replaced by I1. So we can write I1Q equals to, and I4 is equals to I2. So I2R. This is my equation number 2. Okay, in bracket you have to write these relations. Now we will divide 1 by 2. We divide 1 divide 1 by 2. So P1 I1 or PI1 divided by I1Q equals to RI2 divided by I2, RI2 equals to I2 into S. Sorry, here I made a mistake. It will be S. I2 into S. Okay, I1 cancels, I2 cancels, and we get P upon Q equals to R upon S. This is the balanced condition for Wheatstone bridge. This is the balanced condition for Wheatstone bridge. P upon Q is equal to R upon S. Okay, easy derivation, simple derivation, one of the shortest derivation that I have done. If you are using any other books or any other reference or even NCERT derivation, that is much longer. I secured MSRIT ECE branch through Comet K better than KCET. I am wishing for CS allied branches. Will I get in second round? Kindly reply. Akishore. Hi Akishore. You should, if you are getting the seat for via Comet K, you can hold on to your seat. But I don't think that you can without paying the fee. If you are have to pay the fee, then and if you want allied course in RBC, what is your rank? Or MSRIT, whatever. MSRIT, if you are willing to get MSRIT for KCET, what is your 3.5 in Comet K and KCET? So see, if with 3.5 K, you should be able to get a allied course via Comet K. You should obviously you should hold on and try to upgrade your seat. Okay, and possibly you should get a seat for CS allied course once the Comet. Basically, what happens? Everyone applies for Comet K, but as KCET counseling is happening, many students take admission via KCET and they ignore Comet K seat. So there is a high possibility that you will get a allied course seat in Comet K via Comet K for MSRIT. Okay, allied course, I hope that you might, there is a high possibility obviously. Okay, so you should hold on to your seat. Yes, you should get an upgrade. Okay, you should get an upgrade with 3.5K. You should get most likely you will get either data science or in AIML. Okay, the high possibility you will get a seat. Okay, yes, your choice is correct. Okay, yes. Now let's move on with the numerical questions. We have to finish this lecture. Next chapter is short and small. Only this current electricity chapter is bigger. The next chapter will be finished very quickly, so don't worry about it. So that's why I'm taking this chapter little slowly and trying to explain all the concepts. A copper wire of length 50 centimeter and diameter 1 millimeter carries a current of 3 ampere. The number density of free electrons in copper is 8.5 into 10 to the power 28 per meter cube. Calculate the current density, the drift velocity of free electrons, and time taken by the electrons to drift from one end of the wire to the other end, given the value of E is given. Now, in many cases, this type of questions do require calculators, but I recommend whenever you are using calculators, do not start using calculators from the first equation itself. Simplify as much as possible. At the last stage, apply the calculator. Okay, if you start applying calculator from the first line itself, the answer might be little tricky, and you might make some mistakes which you are not supposed to. So first, obviously, is given the length of the wire. Let us write the given data. Length of the wire is 50 centimeter. Okay, diameter of the wire is given 1 millimeter. 1 millimeter diameter means radius is half of the diameter, that is 0.5 millimeter, and 0.5 millimeter means 0.5 into 10 to the power minus 3 meters. Okay. Next, carries a current of 3 ampere. So current here is given 3 amperes. Okay. The number density of free electrons is given. Number density of free electrons 8.5 into 10 to the power 28 per meter cube. Okay. Calculate the current density. How to calculate current density? First option, part A, current density J is current divided by area. So what is current? Current is 3 ampere and area is pi r square. Okay. Area is pi r square, so it will be 3 divided by 3.1 into r is 0.5 into 10 to the power minus 3 whole square. Okay, or 0.5 into 10 to the power minus 3 can be written as one more step I should have been done, that is 5 into 10 to the power minus 4. This is much easier to handle. So it will be 5 into 10 to the power minus 4. So let me write like that, 5 into 10 to the power minus 4 whole square. Okay, area is pi r square because for a given wire the cross section is a circle, right? So it will almost cancel and you get 1. I know this is not exactly correct, but yes, 25 into 10 to the power of minus 8 or 10 to the power of 8 upon 25, and we can write it as 100 into 10 to the power of 6 divided by 25, or it will be 4. So it will be 4 into 10 to the power of 6. 4 into 10 to the power of 6. What is the unit of electric current density? Ampere per meter square. Very important. Without unit, you will not get marks. So make sure you write the units properly. So first step is done. So current density is calculated. Next is the drift velocity. How to calculate drift velocity? Drift velocity is I upon NEA. Okay, I is equal to NEA VD. So VD will be equals to I upon NEA. Okay, let me draw a straight line to separate. Okay, now part B, VD equals to I upon NEA, or VD equals to I is 3 ampere, N is given here as 8.5 into 10 to the power of 28. E is 1.6 into 10 to the power of minus 19, and area is, we have calculated all the same value, 3.1 into 10 to the power of sorry, into 5 into 10 to the power of minus 4 whole square. Obviously very long value. Okay, now we have to simplify this. So this will be 3 divided by 8.5 into 1.6 into 3.1 into 25 into 10 to the power of 28 into minus 19 minus 8. Okay, so this will be the value, and obviously you can see this value is very small. it will come out to be approximately, I am saving myself, the answer is written over here. So I am just taking that answer over here, and it will be 2.8 into 10 to the power of minus 4. Okay, so this will be the drift velocity, and unit of drift velocity is meter per second. Okay, next part, the last part, how much time taken by the electrons to drift from one end to other end. Okay, so how to calculate the time taken by the electron, that is very interesting. So electrons were moving throughout the conductor from one end of the conductor to the other end, and it is drifting with the drift velocity vd. Suppose this is the direction of electric field. So how much time it will take to reach from this side to that side? So for that, obviously, this is like a velocity time question. Length is given, Vd is given, so time taken will be length divided by Vd. Okay, what is the length? Length of the wire is 50 centimeter. 50 centimeter means 50 into 10 to the power of minus 2, and this is 2.8 into 10 to the power minus 4. So this will approximately, not exactly, approximately, it will be uh, 2, say approximately 1.8, 18 into 10 to the power of 2 second, or 1.8 into 10 to the power of 3 seconds. Approximately, this is an approximated value. Okay, you use your calculator to find the value, but 10 to the power value, you keep it separate. Only find the other values together. Okay, and once you do that, you will get the exact value. So this is the time. Remember, drift velocity is just like any velocity, only the distance traveled here is the length of the conductor. Generally, the length of the conductor will be given, and then they will ask what is the time traveled. So remember, after calculating drift velocity, you have to do length divided by drift velocity. Thank you, Akishore. Thank you, thank you. Now let's move on with the next question. Three resistors, 2 ohm, 3 ohm, 6 ohm, are combined in parallel. What is the total resistance of the combination? If this combination is connected to battery of EMF 2 volt and negligible internal resistance, determine the equivalent resistance, current through each resistor, and total current drawn from the battery. So three parts you have to solve. 2 ohm, 3 ohm, 6 ohm are combined in parallel. So 2 ohm, 3 ohm, and 6 ohm. 2, 3, 6. Everything is in ohms, and they are connected in parallel. And the battery is 2 volt. Internal resistance is 0, so we do not need to consider it. Determine the equivalent resistance. What is the equivalent resistance? 1 upon R equivalent equals to 1 by R1 plus 1 by R2 plus 1 by R3. Easy, right? So that is 1 by 2 plus 1 by 3 plus 1 by 6. LCM is 6. So 3 plus 2 plus 1. So 6 upon 6, that is 1. So R equivalent equals to 1 ohm. Okay, so equivalent resistance, the first part is done. Equivalent resistance is 1 ohm. Next part is current through each resistor. So current through each resistor will be different: I1, I2, I3, right? And each of them are connected in parallel. So we can say that 2I1 equals to the voltage. So I1 equals to 2 by 2, that is 1 ampere. Now for I2, 3I2 equals to 2 volt, that is I2 equals to 2 upon 3. And for 6 ohm, 6I3 equals to 2 volt, that is I3 equals to 2 upon 6, that is 1/3. So this is how you calculate all the currents. Remember, current unit has to be mentioned. Uh, Current has to be, unit has to be mentioned. Next is the total current drawn from the battery. Total current drawn from the battery is I1 plus I2 plus I3. right? This is the total current drawn from the battery, that is 1 plus 2/3 plus 1/3, that is 3 1 uh, sorry 1 plus 3 2 plus 1, so that is 1 plus 3 by 3, so that is 1, so 1 plus 1, that is 2 ampere. So this is the total current drawn from the battery. Easy question, just solve step by step, you should get the answer. Next, the terminal potential difference of a cell connected to an external resistance of 4 ohm is 2.4 volt. When the same cell is connected to an external resistance of 9 ohm, the new terminal potential difference becomes 2.7 volt. Find the EMF and internal resistance of the cell. This is a previous year paper, one of the question from previous year papers. Okay, so here we have a cell and internal resistance. Okay, so first it is connected to an external resistance of 4 ohm. Okay, this is E, this is R. So when R is equal to 4 ohm, first stage R equals to 4 ohm. Okay, the terminal potential is given by 2.4 volt. Now what is terminal potential? Terminal potential is given by I into R, which is E minus I small r. So first case, suppose the current was I1, so let me write it as I1. Okay, so this is the first case. Okay, R value is given and I1 R together is also given. Okay, so we can calculate I1 itself. So 2.4 equals to I1 into 4. So I1 equals to 2.4 by 4, that is 0.6. Right, now we will go back to this equation once more. We will write 2.4 equals to E minus 0.6 R. This is my equation 1. This is my equation 1. Now we will form the same equation again using the second given information and let's simplify it. So basically you have to construct two equations and solve it, right? In the second case, R is given as 9 ohm and V is equal to I2R is given as 2.7 volt. So I2 is unknown, R is 9, so 2.7. So I2 equals to 2.7 by 9, that is 0.3. So I2 is 0.3. Now again we are going to use the same equation. I2R equals to E2, E remains same, sorry, E minus I2 small r. So that is 2.7 equals to E minus 0.3 into R. Now let's do one thing. Let's multiply everything with 10. So 24 equals to 10E minus 6R. This makes equation 1. Here also multiply everything with 10. We get 27 equals to 10E minus 3 small r. Okay. So this is equation number 2. This is equation number 1. Now as you can see that E value is same. So if you subtract this minus this, you are going to get the value of R. So let's write 27. Let me write it like this: 10E minus 3R equals to 27, and this becomes 10E minus 6R equals to 24. Now subtract. Minus plus minus, this cancels. You get 3R minus 6, 3R minus 3R plus 6R is 3R. Here you get 3. So R becomes 1. So resistance is 1 ohm. Now use this 1 ohm in any one of these equation to calculate E. So let's take this equation. From 2 we get 27 equals to 10E minus 3 into 1, or 10E equals to 27 plus 3, that is 30, that is E equals to 3 volt. So 3 volt and 1 ohm is the answer. Okay, this is from I think 2025 final board exam. This question was asked. Next, calculate the power dissipated in the 10 ohm resistor in the given circuit. So this is circuit based question. Here we have two batteries. Each of them have some internal resistances and some voltages. So we have to find the power dissipated, not the current. Okay, power dissipated, how to do that? Is there any difference? The first step is same like normal circuit based questions. You have to find the current. Okay, resistance is given. So power dissipated is I square R. So this formula we have to use to find the power dissipated. Suppose this current is I1, this current is I2, then this current will be I1 plus I2. Right? I1 coming from this side, I2 is coming from this side. So total current will be I1 plus I2. So internal resistance is actually can be shown over here. Same with this, internal resistance can be shown over here. Okay. So we will first take this loop, and secondly we will take this loop. Two different loops you have to take. This is loop number 1, this is loop number 2. So first loop number 1. Loop number 1. Okay, for loop number 1, this is the current I1. So I1 must be passing through this internal resistance as well. So I1 into 1, I1 into 1, that is I1, and we are going in the direction of current. So I1 plus I2 into 10. I1 plus I2 into 10 equals to the voltage, that is 2. Okay, so simplify, 11 I1 plus 10 I2 equals to 2. This is equation 1. Okay, next take this circuit and loop this loop. Again we are going in the direction of current, so we can write this into I2, that is 2I2, 2I2 plus 10 into I1 plus I2. This is loop number 2. This is equals to the voltage, that is 4 volt. Okay, so we can write 10 I1 plus 12 I2 equals to 4. 12 I2 equals to 4. Now what? Now you have to basically simplify this. How to simplify this? Equation 1 and equation 2. Multiply this equation with 10 and this equation with 11. So 10 into equation 1 minus equation 2 into 11. So just get that, 110 I1 plus 100 I2, okay, equals to 20, and here we get 110 I1 plus 12 into 11, so 132. So 132 I2 equals to 44. Again subtraction, minus minus minus. So this cancels, you get minus 32 I2 equals to minus 24, or I2 equals to 24 upon 32. So 4 6 ja 24 and 4 8 ja 32, or it will be 3 by 4. So I2 equals to 3 by 4. Now you go back into the equation 1, put the value of I2, you get 11 I1 plus 10 into 3 by 4 equals to 2, or 11 I1 plus, it will be 5, 15 by 2 equals to 2, or 11 I1 equals to 2 minus 15 by 2, so 4 minus 15 by 2. Okay, so it will be 11 I1 equals to minus 11 by 2. Okay, or I1 equals to minus half. Now what is the meaning of minus half? If current is coming minus, don't worry, your answer is not wrong. That means the original direction of I1 that you have assumed is wrong. current is flowing in the opposite direction. After solving this, if your current is turning out to be negative, don't worry. Misty, it depends on your final board results, right? Mystic, if your board results was good, then you can take a drop. Your board results are not that good, then taking drop will not help you, because only 50% you are playing with, 50% is already written for your board exam, right, Mystic? So if you are taking a drop, make sure if your board results are 85% and above, then you can take a drop, because every year the cutoff will be difficult. Every year board results will be better, students will do more good than previous year. So if already your board exams results are good, if you have 70% board results, you should not take a drop. Whatever college you are going to get, take admission. But if you are say you have already secured 85-90% marks in your board results, okay, at least 85 minimum, 90% plus is better. If you have that kind of marks, and only your KCET results, KCET exam was not good, then you can take a drop. Okay, right, Mystic? I hope that helps. Now let's move on. I1 is equal to minus half. Now let's try to find out the total current. Total current is I1 plus I2, which is 3 upon 4 minus half, which will be 3 minus 2 by 4, that is 1 by 4. Okay, so this is the 1 by 4, this is the current. So what is the power? Power is I square R, which is 1 by 4 whole square into 10, that is 10 by 16. Okay, so this is the answer, and the unit of power is joules per second. Okay, unit of power is joules per second. Okay, now let's move on with the next chapter, moving charges. Moving charges. If a current I is flowing in a straight line, straight wire parallel to x-axis, and magnetic field is there along y-axis, okay, so current is flowing along the straight wire parallel to x-axis, and magnetic field is there along the y-axis. Okay, then the wire experiences a force in the x direction. So remember, parallel current is x, okay, and current is x, magnetic field is y. Okay, so if you remember, the force acting on a wire is given by I L cross B. The direction of L vector is along the direction of current. Okay, so L cross B means, so if you point your finger like this, L cross B means the force acting on the wire is along the z direction. Okay, z direction is the cross product of x cross y, gives you z. So that means L cross B will give you the z direction. So the wire will experience as a force in the third axis, that is z direction. Now positive z or negative z, if this is positive, then z will also be positive. Okay, now let's move on. The Lorentz force is the force on a charged particle moving in a region containing only electric field, only magnetic field, both electric and magnetic field, only crossed electric magnetic field. I don't know what is crossed electric and magnetic field, so it will be both electric and magnetic field. Okay, now let's move on. A moving coil galvanometer can be converted into a voltmeter by connecting. So moving coil galvanometer can be converted into a voltmeter by connecting a low resistance. I think this is not required for your FA-1, but anyway, let's see. Moving coil galvanometer can be converted into voltmeter by connecting a high resistance in series. Okay, so this is the answer. Next, force on a charged particle moving in a magnetic field is maximum when the angle between them, between the velocity and charge of the magnetic field is. So the charge and magnetic field is maximum. So we know that force acting on a charged particle is q v sine theta. Okay, so when sine theta is maximum, the force acting on a charged particle is maximum. So that is 90 degrees. When the charged particle is moving at an angle 90 degrees with the magnetic field, then the force acting on the charged particle is maximum. Next, a charged particle released from the rest at a region of uniform magnetic field, a magnetic and electric field parallel to each other. The particle will move in a. So here magnetic and electric field both are parallel to each other, not perpendicular. Particle is released from the rest. So when you release the charged particle in the rest, okay, the particle is moving. Particle will move in the direction of electric field. If the particle is positive, assuming particle is positive, it will move in the direction of electric field. Magnetic field, on the however, will not apply any force because it is qvb sine theta. In this case, theta equals to 0. So magnetic force will be 0. So this will be a straight line motion. This will be a straight line motion. When do you observe circular motion? If magnetic field and the direction of motion is perpendicular to each other, we see a circular motion. If there is a component of force which or component of velocity which is not perpendicular, that means the angle is not 90 degree. Okay, then we see helical motion. Okay, if the angle is say 45 degrees or 50 degrees or 60 degrees, in that case we see helical motion. If the angle is 90 degrees, we see circular motion. If the angle is 0 degree, we see straight line motion. Okay, next, the dimension of magnetic moment. What is magnetic moment? Magnetic moment is given by current into area. Current into area is called magnetic moment. So its dimension will be unit will be a ampere meter square. So dimension will be al square. Okay, dimension will be al square. Here l square a. Okay, so l square a is the dimension of magnetic moment. Next, a charged particle is moving perpendicular to the magnetic field. Its speed increases, then its radius will be. So we know that qvb equals to mv square upon r. So r equals to mv upon qb. Okay, we will do this derivation as well. Don't worry how it is coming, we will explain. So r is equal to mv upon qb. So if velocity or speed increases, radius should increase as well. So if a moving its speed increases, radius also increases. Okay, radius and velocity are directly proportional. Next, when the charged particles move in a combined, yes Akash, I think you answered correctly. So answer this, fill in the blanks, right? When the charged particles move in a combined magnetic and electric field, then the force acting on it is known as. So it is a combined electric and magnetic field. Then what is that force is called? Ampere circuital law, infinity, Lorentz force, Laplace law, right hand thumb rule, magnetic dipole. So it is called Lorentz force. Okay, the spelling is very interesting. Lorentz force. Okay, the direction of magnetic field due to a current loop found using the direction of magnetic field due to a current loop. So if you are trying to find the magnetic loop, you always use right hand thumb rule. Okay, so remember, if this is the current direction, this will give you a north pole. So this, if this is the direction, you will get a north pole, and if opposite, you get the south pole. Okay, if it is in this direction, this is the north pole direction. If this is the direction, this is the north pole. That means this side is south pole. Okay, it is using right hand thumb rule. The answer is right hand thumb rule. Right? Yes. Next one, Akash, last one. Current carrying circular coil is equivalent to. Current carrying circular coil is equivalent to Ampere circuital law, infinity, Laplace's law, magnetic dipole. What is the answer? Last one. Yes, correct. It is magnetic dipole. Okay, correct. Now, next is some two marker questions. When does a current carrying conductor placed in an uniform magnetic field experiences maximum force and minimum force? A current carrying conductor placed in an uniform magnetic field experiences a force given by F is equal to Bill sine theta. Okay, so the force will be maximum when sine theta is maximum. When sine theta is maximum, when the theta is 90 degrees. So force is maximum when theta is 90 degrees. Force is minimum when theta equals to 0 degrees. So if you are writing this answer, always first mention what is the force, then write theta equals to 90, theta equals to 0. Many students do not write anything, they just write force is maximum when theta 90. Which theta? What is theta? Right? So either explain what is theta, or you have to write the expression and then you have to mention that the theta is actually the L vector and the magnetic field vector. The angle between L vector and magnetic field vector is theta. Okay, generally L vector is taken in the direction of the current. Okay, now next, state and explain Biot-Savart's law. If this question is coming, you have to draw the diagram and explain the diagram. Not explaining the diagram, but diagram you have to show the point where you are measuring the magnetic field, and everything has to be pointed properly. The magnitude of magnetic field at any point P due to the current element dl is directly proportional to the strength of the current I, directly proportional to the length of the current element dl, directly proportional to the sine of the angle between the current element and the line joining the given point and midpoint of the current element, and inversely proportional to the square of the distance between the current element and the point. So many of you just write that uh, B is proportional, or write dB is proportional to I. Okay, dB is proportional to L, dB is proportional to sine theta, dB is proportional to 1 by r square. So if you are writing that, in that case you have to mention what is I, what is L, what is sine theta, what is r. So if you mention that, then only you will get the marks. If you just write this, you will not get any marks. Many students do not draw anything, do not write anything, they just write dB proportional to I, dB proportional to L, dB proportional to sine theta, dB proportional to 1 by r square. Do not do that. Please explain what is that. Okay, and the diagram is compulsory for Biot-Savart's law. Without the diagram, marks will not be you will not get the full marks. Okay, clear? So marks are super important. The diagrams are super important. Derive an expression for angular frequency of revolution or radius of circular path for a charged particle moving perpendicular to the uniform magnetic field. Okay, so you have to show that in a uniform magnetic field a charged particle is rotating. Okay, and you have to find the expression for the angular frequency. Angular frequency means angular velocity, actually, omega. Okay, and suppose this is the charged particle, this is the radius r. Okay, either you have to find the radius, the velocity of the particle is given by v. Now whenever there is a circular motion, you always need to remember, in case of circular motion there always have to be a centripetal force required for a circular motion to continue. If there is no enough source to provide the required centripetal force, the circular motion will not take place. Centripetal force is not like gravity or electrostatic force. It is required. It is a necessity. Okay, so if, for example, if you want to travel, say, from Bangalore to Mysore, you have to pay some money. Okay, you have to pay some money for the train or bus fare, right? It is a necessity. Someone has to provide that money to you, and then only you will be able to pay the money to the conductor or the ticket collector, so that you can travel. right? If you do not have the money, you will not be able to travel. Same thing with the centripetal force. Centripetal force is like the fare that is required, and someone has to provide that fare, so that the circular motion is happening. In different cases, different sources provide the required centripetal force. One very common example, the satellites which is orbiting around the earth. Okay, who is providing the required centripetal force? We are not able to supply enough fuel to this satellites constantly, right? So it is rotating automatically. So who is providing the required centripetal force? The gravity is providing the required centripetal force. So the motion is free. We do have some fuel in that, just to adjust its path, correcting its path. Sometimes it falls down a little bit, so to just adjustment we have a very small amount of fuel. Otherwise it is entirely dependent on gravity, and gravity is providing the required centripetal force, so that it is orbiting around the earth. For any circular motion, we always need some source to provide the required centripetal force. So when a charged particle is rotating in a magnetic field, suppose this is a magnetic field, into the page of the paper, cross means into the page of the paper, then the Lorentz force, or the magnetic component of the Lorentz force, is providing the required centripetal force. So we can write the magnetic force is equals to the centripetal force. Now what is the magnetic force? Magnetic force is Q into V into B. Sin theta is there, but because the angle of velocity and angle of magnetic field are 90 degrees, so we are not writing the sin theta. And what is centripetal force? In your first PUC you have studied centripetal force is given by mv square upon r. Same velocity, velocity is same, this both sides velocity is same. Okay, so we can write one of the v will be cancelled, so we can write mv upon r equals to q into b. Now let's find the radius of the path first. So radius of the path will be mv upon qb. Radius of the path will be mv upon qb. That's it. Okay, just do the cross multiplication, you are done. What about angular frequency? Angular frequency or rotational velocity is given by v upon r. Okay, rotational velocity is given as v upon r. V is equal to r omega. V is equal to r omega, or omega is equal to v upon r. So this equation we are going to use again. Okay, mv upon r equals to qb, or v upon r equals to qb upon m, or angular frequency is equal to qb upon m. If they ask you time period is 2 pi by omega. Time period is the total time required to complete one full circle. So that will be 2 pi by omega. So that will be 2 pi m by qb. Okay. So all these three derivations are possible. Okay. And any one of them can be asked. So you should practice this derivation, easy derivation. If you practice once, you should be able to do it in the exam hall as well. Next, what is Lorentz force? Write its expression and explain the terms. Force acting on a moving charge particle in the presence of electric field and magnetic field is called Lorentz force. Lorentz force have two components. One is electric component, one is magnetic component. So electric component is Q into E, and magnetic component is Q into V cross B. Remember, it's a vector quantity. That's why we have to, when you are being asked Lorentz force, do not write the scalar from, try to write the vector from itself. Okay, so E is the electric field, V is the velocity of the particle, B is the magnetic field, and Q is the charge, right? So this is the expression for Lorentz force. This is also super important, heavily important question, and it has been repeated again and again throughout the history of board exam. Okay, now this is the last question of the day. Derive the expression for magnetic field. Also I will tell you how to download the notes once more if you have missed it, so I will tell you that as well. Derive the expression for magnetic field at a point on the axis of a current loop. So here we have a current loop, okay, and we are actually trying to find the we have to find the magnetic field on the axis of this loop. Okay, we have to find the magnetic field on the axis of this loop. How to do that? So for that, suppose we are trying to find the magnetic field at this point P. Okay, so we have to take a small element dl. Start with a small element dl and apply Biot-Savart's law to find the magnetic field. So this is the distance. Let me do one small change. Let me do one small change. Okay, this distance say is r. Okay, this is x, and the radius of the circular loop is capital R. So circular loop is the loop is kept like this, and we are trying to find the magnetic field at this distance. Okay, circular loop is not like this; it is kept like this. Okay, so this is the loop which is kept like this, and because of that loop, you are trying to find what is the magnetic field at some distance. Okay, so don't be confused. This looks like an ellipse. You might say, sir, this is looks like an ellipse. This is not a circular loop. So how to do this? Basically, it's a loop which is kept like this, and on its axis, we are trying to find the magnetic field. Okay, so this is the element dl, and this element dl is making an angle 90 degrees with the direction vector. So from Biot-Savart's law, the magnetic field expression is given by dB equals to mu naught by 4 pi I dl by r square. Okay, this is the dB formula for Biot-Savart's law. From Biot-Savart's law, the magnetic field due to a small element dl is given by I dl upon r square. Okay, now this is the direction of this is again in the this direction. Obviously, it is not along the axis. So what we have to do this for this thing, it will be very complicated. All the point individually, all the points will have a different direction. Okay, this will be some perpendicular direction to both. Then you will be getting a magnetic field along this. Okay, magnetic field will be each and individually will be separate point for individual element. If you take different elements, for each and every element the direction will be different. So taking the vector sum will be much more difficult than if you can figure out how to simplify it. So we will be basically taking two components. One component is along y direction and one component along x direction. Okay, we will call this is dB, this is dBx, and this is dBy. Now if you see that, because the radius is fixed, the distance is also fixed. No matter where you go, this distance r will be same. Okay, because this is a cones kind of structure, right? So this distance small r will be same for each and every point. That means the x and y component magnitude wise will be same at each and every point. So if you consider exactly a point which is diametrically opposite, okay, then you will see that the dBx will be in the same direction, but dBy will be in the opposite direction. So this will be in like this, right? So dBy, dBy, both cases dBy will be cancelled, but dBx's will be added. So if this angle is say phi, this angle will also be phi, and you can say that dBx, which we actually want to find, will be dB cos phi. Okay, y component will cancel each other due to symmetry. Clear? Now we have to find this dBx fellow. So how to do this dBx fellow? We will write dBx equals to mu naught by 4 pi I dl upon r square into cos phi. Okay, obviously dB into cos phi. Right, now what is cos phi? So if you check this diagram, you will be able to find the cos phi. Cos phi is base upon hypotenuse. So that means mu naught by 4 pi I dl upon r square capital R by small r, right? So that means it will be mu naught by 4 pi I r upon r cube into dl, okay, into dl. Now this is due to the small element. Now if you take integrating the entire circular loop, you take small element across this, you have to integrate it. Okay, integration may not have been completed in your uh, mathematics yet, but once it is done, it is very easy thing. Okay, not a difficult one. Just remember that close integration means starting point and ending point are same. We have done the same thing in case of Gauss's law also. So Gauss's law, we know that for surface integration, it is the surface area. Here we taking length, so that means it will be the total length of the circle. Length of the circle means perimeter of the circle, which is given by, so mu naught by 4 pi I r upon r cube into in close integration dl. Close integration dl means starting point and ending point are same. And here you are going to get the total magnetic field. Magnetic field is given by mu naught by 4 pi I r by r cube into 2 pi capital R. Capital R is the radius, so 2 pi capital R. So pi cancels, 2 cancels, and you get the magnetic field along x component, along the x axis is given by mu naught by 2 I r square upon r cube. Now this is not done yet. You have to put the value of small r. Small r is not the distance. Distance is x. This is r. So small r is actually square root of capital R square plus x square. So small r cube will be r square plus x square to the power 3 by 2. So now we put the value mu naught by 2 I r square upon r square plus x square to the power 3 by 2. Okay, so this is the expression for magnetic field on the axis of a current carrying loop. This is a very important derivation, and that derivation will last you till your PU board exam. So if you practicing it now, you don't need to do a very hard work during your board exam. Okay, practice it now and it will stay with you till your board exam. So whatever you are practicing now, always keep in your mind that ultimately you have to write your PU exam, and whatever you are learning now, you should remember everything. And how can you access to our notes? So just give you a demo of how can you access our notes. Just a second. So these notes will be available here. Okay, so you have to visit our YouTube channel. Once you visit our YouTube channel, click on the read more of the description of the video, and here you have to click on join the free ACE KCET 2027 course. Click here. Okay, and then this page will open. Here you have to register yourself. Buy now. Price is 0. You don't need to pay anything. Just click on the buy now. Use your mobile number and some basic details. As soon as you are done with the registration, okay, you will receive a OTP. Every time you log in, you will receive a OTP, and put the OTP, and then you will be redirected here. You can click on this course, and then you get all the lectures that is being done over here. And as you can click here, you will get the all the notes will be added in this page. Okay, so FA-1 full marks physics, electrostatic and potential capacitance, that is already updated. Other chapters that we have done, all will be updated over here only. Okay, so you will get everything in this sheet only. You don't need to go anywhere. You don't have to look in YouTube, sir, when that lecture happened, when the lecture I missed it, I am not able to find it. Don't worry, all the KCET and PU related lectures will be updated over here only, right? And you will get all the notes over here also. and you can check all the videos. There will be Ved AI support also. You can ask Ved AI any questions that you want, right? What else you want? Register yourself today and thank me later tomorrow, right? So the link is there. Go to in the description section of this video. And obviously, if you have not yet subscribed to our channel, don't forget to subscribe. Subscriptions are important. And if you feel that this video is helpful to you, don't forget to like it. And obviously, I'll be back with more some contents for your FA1 till Monday also, because obviously Monday you have most of the students have physics paper on Tuesday. Okay, so I will do something on Monday as well. Okay, I will see you till then. Bye. Hello.